What we want to do in factoring number 3 is just clear up a few little loose ends from section 4.3 of the book. One of these is the zero product property. We've discussed the concept in class, but we never really gave it an official name. So the concept goes a little something like this, that if 3 times a value is equal to 0, then that value must be equal to 0. Well, then it serves to say that if you have a value inside of parentheses times another value inside of parentheses equal to 0, then either A or B is equal to 0. And what we do is we take those values and set them equal to 0 respectively, as you see up here. And that leaves you with a value of -5 and -2. Moving on. There was a problem in the homework that involved some factoring that you were not accustomed to, and number 35 and 36 here represent very similar problems. 35 has u squared equal to -9u. Now, as I've said in the previous video, when you're solving quadratics, you want to get your values set equal to 0. Since the u squared is positive, what I'd like to do is add 9u to both sides. And then the reason I'm choosing to add 9u is because adding 9u to -9u would make the right side equal to 0, which is what I want. Now I'm just going to write the left side in powers of descending order. So u squared being the highest power, I'm going to leave that to the left. I want to keep that quadratic term, or the coefficient of the quadratic term, which is technically 1 out here. I want to keep that positive if possible. It just makes the factoring easier. Now, as I look in both terms, what I see is that both of them have something in common. They have a u in common. And so what I want to do is I want to factor that u out. When I'm factoring out a u, I'm essentially dividing both terms by u. U squared divided by u is u, and 9u, positive 9u divided by u is equal to 9. If you take a minute and you actually look at what we have here, if I redistributed the u back through this set of parentheses, u times u would be u squared, and u times 9 would be 9u. So this is the correct factorization of u squared plus 9u. Now what we're going to do is take into consideration what we just discussed in our zero product property. And I have u times u plus 9 equals 0. So u is equal to 0, or u plus 9 is equal to 0. And I'm going to end up with answers of u equals 0 and -9. And it'd probably be a little bit more pizzazzy to write our final answer as u is equal to -9 and 0 as a final answer. Always just sort of keeping the constant of the smallest number to the left. All right, let's move on to 36 then. Very similar program here. I'm going to stick with the white. M squared equals 7m. We want to set this equal to 0, so we subtract 7m from both sides. Notice I don't write it under the m squared because I can't really subtract 7m from m squared, so I just write it off to the side. And when I rewrite, I write the m squared first, minus 7m equals 0. I look at both of my terms. I see that there's an m available, a common monomial in each of those, so I'm going to factor out the m out there, and I'm left with m squared divided by m is m, -7m divided by m is -7 equals 0. Now I take both of those factors and I set them equal to 0 individually according to my zero product property. Again, if a times b equals 0, then either a or b is equal to 0. So I set them both equal to 0. M is equal to 0. M minus 7 is equal to 0. And then my final answers are going to be 0 and +7. And there we go. What you're going to start noticing is that we keep using the words interchangeably, x-intercepts, roots, and zeros. They're all referring to the same basic location. So generically, I'm just going to sort of draw a random parabola here. if I took this parabola, what we're referring to are these locations. So those two black dots are the roots of the equation. They're the x-intercepts of the parabola, and they also serve as the zeros. All of those are all referring to the values of x that make y 0. So when I see this question, what are the roots of the equation of x squared minus 5x minus 36, is essentially what we're talking about are the zeros, or the x-intercepts. So I say, okay, I'm going to set this equal to 0, factor, set my factors equal to 0, and solve for x. So I have x squared minus 5x minus 36 equal to 0. And now what I'm going to do is factor this side, so everything's still going to be equal to 0. I look for some common monomials. There's nothing common variable-wise in all three terms. There's nothing common numerically in all three terms, 1, 5, and negative 36. There's no sense in factoring out a 1. So I'm left with the choice of just splitting up my two binomials. And I notice that 36 is negative, which means that my signs are different. And that means that this negative 5x is the difference of the two factors. So I have x and x, two numbers that multiply to give me 36, and have a difference of 5 would be 9 and 4. All right, that equals 36. And I want a negative 5x as the difference, so my negative is going to be the bigger number, and my positive will be the smaller number. And when I look here, I just kind of quickly look, that's going to give me a positive 4x, that's going to give me a negative 9x. When I combine those like terms, I'm going to get a negative 5. That's excellent. So now I'm just going to set these equal to 0. X plus 4 equals 0. X minus 9 equals 0. And I'm going to get a final answer of negative 4 and positive 9. I look up in my multiple choice, and that would be choice C. So when I'm doing multiple choice problems like this, even though it's multiple choice, I still expect to see all of this work. You're going to want to take a minute and press pause and essentially copy this whole slide down. I'm not going to rewrite anything. I'm just going to be referencing here. But you're going to want to take a minute and copy everything down with the exception of B. Everything else refers to question A. Go ahead, pause now. Okay, so as you notice, the previous slide referred to the roots of the function. Now we're referring to the zeros of the function. Same basic concept, same method of attacking. It's just that this one says that we're going to rewrite the function in intercept form. But intercept form is f of x equals a times x minus p times x minus q. So really what we're saying is, let's factor this thing. So as you notice, we start with our function. They leave the y off, and it just means that it's just sort of trailing down on the left side without writing it. It's just implied. And on the right side here, we have a negative 12, so we got the positive and negative. Two numbers that have a difference of negative 1 and multiply to 12. It's 3 and 4, of course. This is a negative 1, so the negative is going to be the 4, the bigger number. The positive is going to be 3. And they don't show you what when you set those equal to 0, or if you're thinking about this in terms of intercept form, you're looking at the opposite of p and opposite of q, so we're going to flip-flop those signs. And of course, our actual values of p is negative 3, and our value of q is 4. So when we look at this graph, we have zeros at negative 3, 0, and 4, 0. Zeros, fancy for x-intercepts. And how could we check it? We could use a graphing calculator, a graphing utility. So if you notice, this is the top part of the screen here. And where does this parabola cross over the x-axis? At negative 3 and at 1, 2, 3, positive 4. Which means going to y equals and placing this very function into your y1 or y2 or whatever, and hitting graph and taking a look at the graph, or taking a look at second table and then going to x values of negative 3, and you'll notice that the y value is 0. You can also use the trace function. There's lots of ways you can use the calculator to help you check your final answers. Okay, so now we've reached the goal, the application of our quadratic skills. A town has a nature preserve with a rectangular field. Okay, so this thing is rectangular. It measures 600 by 400 meters, and the town wants to double that area. All right, so when we take a look over here, here's our original rectangle. So the area currently is 400 by 600. That's equal to 240,000 square meters. They want to double that. So 2 times 240,000 is 480,000. That's the area they want the new measurement. That's going to be the new area. Okay. Well, what are the new dimensions? The new dimensions are right here listed in the picture. 400 plus the x on the width or the base, and 600 plus x on our length. So I'm going to say that area is equal to base times height. Or you could write it as base times height equals area. It doesn't matter, however you're comfortable. And I'm going to say that our new base is 400, x plus 400, or 400 plus x, times x plus 600, right? That's our base times height equals area, keeping in mind that the new area is going to be 480,000. Now what I'd like for you to do, press pause, FOIL that out, subtract or deal with this 480,000. So after you FOIL the left side out, you're going to get some big numbers, okay. FOIL that out, subtract the 480,000, set this thing equal to 0. Okay? Take a minute or two, do that on your own, press pause. Seriously, press pause and try this on your own. Now you should have what I have, x squared plus 1,000x minus 240,000 after you FOIL it and subtract 480,000. So what we're going to do now is do what we know how to do. We're going to factor. Our 240 is negative, so that's a plus and a minus. It's going to be an x, and an x gives us x squared. And now two numbers that multiply to 240,000 and have a difference of 1,000x. Well, basically what we're looking at here is sort of 24 and a difference of 10. So, or I should say 240 and a difference of 10. Sounds like kind of like a 12 and 2 combination. Only it's not exactly 12 and 2. More like 1,200 times 200. And the difference of 1,200 and 200 happens to be 1,000. Okay, so that 1,000 is a positive difference, right? So we want our bigger number to be the 1,200. So 1,200 goes here, and our 200 goes here. And just take a minute to think about this. That's going to be positive 1,200x. That's going to be minus 200x, and 1,200 minus 200 is the 1,000 that we're looking for. And 1,200 times 200 is 240,000. So we're good to go. Now, this, applying the zero product property, I'm going to get x plus 1,200 equals 0, and x minus 200 equals 0. And I'm going to get x of negative 1,200 and positive 200. But in this problem, x actually represents a length. So it's not possible to have a negative length. So I'm going to discard my negative answer and just hold on to the 200. Find the new dimensions of the field. That's the goal of this question. So we're not done yet. We just have the value of x. So it's going to be 400 plus the 200 is my new width, and my 600 plus the 200 is my new length. And is 600 times 800 equal to that 480,000? Is that double? Let's see, 6 times 8 is 48 plus the 4 zeros. So indeed, that's 480,000. So we have a 600 by 800